The next topic is right off the backboard of what we just did. We're going to start doing arithmetic with fractions. And I'm going to say the next two operations are easy, and the last two are super hard for some people. They? So we're going to do the easy ones first. Multiplying fractions. Multiplying fractions. Okay. So, if A, B, C, and D are whole numbers, we'll call those whole numbers. And non-zero. We're not dealing with zero. This means R in math. You're going to see this a lot from me because I'm lazy. I'm not going to write is a whole number. I'm going to write this. So that means we have these numbers. A, there's one fraction, and here's the other fraction. If we multiply these, the result is A times C over B times D. You just multiply straight across. Okay? Now, it's always better to reduce before you multiply.
Right.
If you can reduce this number with either of these, or this number with either of these, if you can reduce one of the numerators with either the denominator, then the answer is going to be a whole lot easier to find. Okay? Because you'll be dealing with smaller numbers. Let's do an example of one that is not small first, just so we can see how to do this. 3/8 times 5/11. Okay, so we multiply across the top, 3 times 5, and then on the bottom we have 8 times 11. None of these numbers can be reduced.
Right.
Because they are what's called coprime. Coprime means they share no common primes.
It means what now?
They share no common primes.
Okay.
Look, the only primes that come out of 8 are 2.
Right.
3 and 2 aren't the same. 5 and 2 aren't the same. 5 and 11 aren't the same. 3 and 11. These are all prime. So they're called coprime. Now multiply what's left. 3 times 5 is
15.
And 8 times 11 is
88.
And that's our answer. So, if for some reason that let me kind of visualize what this is, because it's not easy to visualize what we're doing here. And that's kind of important. Why are we multiplying fractions? So, bear with my drawing. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So that's I'm going to use 5/11s here. So this is 1, 2, 3, 4, 5. Okay. So if I was to split this into 8 parts, the 5/11s into 8 parts, 1, 2, 3, 4, 5, 6, and pretend they're equal parts, and then take 3 of those, like this, just these 3. In comparison to the whole, this fraction would be 15 over 88. And look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Out of a total of 88 squares. Pretty neat, huh? That's where this comes from. Okay. I'm so glad that came out. Sometimes it don't come out because you do it wrong. But okay. But let's do some examples where we may have to reduce before we multiply. And we're also going to look at some examples of mixed numbers and improper fractions. First one, 4 11ths times 2/3. I think I was very easy on this one too. Okay, so do 4 and 11 have common factors?
No.
No. Do 4 and 3 have common factors? No. Do 2 and 11 have common factors? No. They're all coprime. So now we can multiply straight across. 8/33. Easy schmeezy.
Easy peasy.
B. What happens if we have a whole number times 7/12? Okay, so now we got a whole number we're going to multiply. I want to take 7/12 and then multiply this number by 5. I want 5 times this. Or I want 5 split into 12 parts and take 7 of them. However you want to do that. Okay. Well, when we have a whole number, we just write it as an improper fraction, 5/1. Because you can always write a whole number as a number with 1 in the denominator. And then we just do what we just did. And I'm pretty sure 5, 7, and 12 are coprime. There's no common factor. This is 3 times 4, right?
Right.
And 5 and 7 are prime, so we just multiply across. There's nothing to reduce. 3 times 7 is...
No, 5 times 7.
5 times 7 is 35/12.
Wow.
Now, a lot of questions on this one. How do I answer? Can I leave the answer in an improper fraction? Or do I have to go to a mixed number? Hang on a second, I'm taking my sweater off. It's hot. Do I have to go to a mixed number? Well, the question is, well, for a class-related thing would be, well, do what your instructor says. But in the real practical world is how are you going to use this number? You could say that this number is almost 3. It is. It's pretty close to 3. You see how it's pretty close to 3?
Yes.
So let's go ahead and divide it out and prove that it's pretty close to 3. If I take 12 and go into 35, and I lost my glasses. They're on the floor somewhere. I hope I don't step on them. 24 and 11. Yeah?
Right.
Okay, so this is 2 and 11/12. And 11/12 is pretty darn near 12/12. So that's almost 3.
Right.
Okay. So this number might tell you, this number is going to tell you more than this number is in practical real world. Okay, there they are. Now I can see. All right. Okay, let's look at some more. I think, yeah, this next one we're going to be able to use that reduce before we divide. More than once. Okay. Good. This is one of the ones I want to see. 2/3 times 3/7. 2/3 times 3/7. Okay. So let's start here. 2 is prime and 3 and 7 are prime. So there's nothing that we can cancel out there, right? You can't reduce this way and you can't reduce this way. But 3 and 3, those can reduce to 1, right? And what's left?
2/7.
2/7. That's probably the easiest one and the easiest problem we've done so far in the whole history of the class. Okay, now to do the dreaded hard one. Oh no, not the dreaded hard one. 3 2/5 times 1 1/2. Okay, this is the downside of mixed numbers. You can't multiply fractions in mixed number form. You have to convert them to improper fractions. Have to. So let's do that using the formula we used in the first lecture. 5 times 3 is 15, and 15 plus 2 is 17. So the first fraction is 17 over 5. Denominator stays the same. And 1 1/2, I think we burned that enough the first part of the lecture. What's 1 1/2 as a mixed number?
3 over 2.
3 halves. Yes. 3 over 2. Oh, look at those. Those are all prime. I'm laughing. I'm coughing so hard. Okay, so 17 times 3 is 51. And 5 times 2 is
10.
10. Okay, so let's go back to a mixed number. 10 goes into 51 5 times with a 1 remainder. And let me write that out for those people that... Okay. Oh, there you go.
There you go.
There we go. Okay.